So, do you want to keep your Raspberry Pi happy, tuned up and well maintained? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots and projects, bring them to life with code, and have a whole load of fun along the way. Okay, let me just hit the mute button there and let's get over to some quick slides. There we go. Okay, so yeah, only a couple of slides basically on this one. It's going to be pretty much a demo throughout the entire video. So yeah, this is how to make your Raspberry Pi 10x its life cycle. So I've got one of the very original Raspberry Pis here. This one still runs, and I've got one on the desk as well that we'll have a look at in a second. And this one is also an original Raspberry Pi. You can see the SD card sticking out there. You can also see on the top there, it's got this like a little yellow composite video out as well. That's the original Raspberry Pi. This one was signed by Eben Upton when I met him at the 10th anniversary of the Raspberry Pi. So we're going to have a play with this. This is a little model that's I made from Adafruit. I think it's one of the very first things I 3D printed. It's like a little Mac mini case, and it's running live. We can type things on this keyboard here. You can see there that it's actually running Raspberry Pi OS. Actually running the latest version. So let me get over to my slides. So yes, the very first thing we're going to be looking at, one of the tips. You might require this one yourself from time to time, particularly if you've got an SD card that's got a really small amount of memory. So let me just grab one of these. I've got a little graveyard here of SD cards that have not quite made it for one reason or another. We'll get into that a little bit later on. But this one here, this is an 8 gig card. That's probably about the minimum size you could probably get away with a Raspberry Pi OS doing anything kind of useful on a Raspberry Pi nowadays, I would say. So let's get into how we would do this. Now I've got some notes over here that I put together on kesrobots.com, so if you head over to there you can kind of follow along, but these are the notes I'm going to be reading from on my other screen, so I'm just going to move them over there so I can read them at the same time and then present to you. So let me tell you about how we're going to do this. So I've got a number of different Raspberry Pis hooked up here. What I'm going to do, I'm just going to go to me for a second. I'm going to load up this one over here. So this is a Raspberry Pi. I'm using the Raspberry Pi Connect software, which is free. You can get this installed on any Raspberry Pi. You just have to be running the latest Raspberry Pi OS, which still runs on the very original Raspberry Pi. So we have this Raspberry Pi here. I think this is the 256 meg version, and I've got the 512 meg version as well on the desk. But this is actually connected to a Raspberry Pi 4, and we've got some issues on this machine. We're going to try and find some large files on here. So let me just clear the terminal. I'm going to make this a little bit bigger so you can actually see what I'm doing. I'm going to zoom in a little bit. And then we're going to get into what the kind of issue that we might find on here. So removing large files, what kind of problem do we have here? So over time your Raspberry Pi can fill up with large or unnecessary files, which can slow down the system and even stop it from working. Usually it can boot, but very quickly you'll find that the services don't start, you can't install things, sometimes you can't even remove things, and you certainly can't update the software. You'll get no space left on device errors, performance might be very slow, and the inability to save files and run software as normal. So what we need to do is find some files that we don't want to be installed on here, particularly the larger files, because the larger files we can remove, we get more space back quicker. So the first thing I'm going to show you on here is how do we know how much disk space that we actually have. So if we type df for disk full or disk file system, we can see here we've got a number of blocks. Now blocks are not particularly human readable, human friendly. So if you do df space -h for human readable, we actually get the megabytes, gigabytes and bytes in size. So we can see on here the available space that we have. We're looking for our root file system. We've got 27% in use. We've got 20 gig available on this particular machine, so we've got actually tons of space on here. But for example, let's say we wanted to find where is all the space being used on here. So there are some utilities that you can download, and one of the easiest ones is called NCDU. So if I press NCDU, we can see here a breakdown in order of size where all our space is being used. And to install this one, you can simply do sudo apt install NCDU. Now obviously if you've run out of space, you're not really going to be able to install this until you've freed up enough space to install this utility, but it is quite small, so you might only have to free up a little bit of space. But I'm going to show you this one first. This is one of the easiest utilities to use, NCDU. It'll start from whatever folder you're currently in. So we want to know what folder we're currently in. If I type in pwd, that'll tell me I'm in the /home/kev folder, so the home directory. So go into NCDU, and I can see there we've got bookshelf, that's taking up quite a bit of space, 54 meg. We've got some config files, and we've also got this 100 meg of clustered pi. So clustered pi is a repository, a GitHub repository that I've downloaded onto this machine, and it's where we have a lot of files that I use for a lot of my projects. So we could remove that one, and we can install that again later on if we need to. So that'd be a very easy way to do this. But let's go into the bookshelf one. We can see there's a beginner's guide. If I press D, that will ask me, do I want to delete that file? So I can say yes, and I've immediately got that space back. So I could go back, I could do the df-h, and I can see that I've got a little bit more space back now. So it's marginal because it was such a small file to begin with, that particular one. So there are some other ways that we can find large files. I'm just going to, if I have that to hand, that command, let me just find that in my notes there. Just bear with me a second, I thought I had that one to hand. So I'm just going to find that's there. So large files. Okay. So I'm going to use the find command. We type find and then the slash, and then we can specify the size of file that we want to find. So if we do dash size, and then we specify anything that's over, say, 50 megs in size, and it'll go through and it'll try and find them. Now obviously it can only find files which it has permission to look in. So we can see on here we're getting a few permission denied ones, so we can run that as sudo if we wish. So an easy way, if you type sudo and then bang bang, it'll run the previous command but under a super user. So what we can also do is just add to that the H for human readable, and it'll make it, no, it's not happy with that. So we'll just have to look and see. So there was one thing there that was quite large. So system journal, we'll come back to the system journal files in a little bit later on, because they are something that we can do something about. Okay, let me get back to my notes. So let's scroll back to there. So how often do we need to be looking for space? It's probably a good idea to look at this, say, on a monthly basis, just to make sure whatever you're using your Raspberry Pi for, it isn't likely to run out of space anytime soon. So probably a monthly basis is more than good enough, 1 to 2 months, just to check on your storage. Okay, so that's the very first one I wanted to cover off. So next up we have tip number 2, which is keeping your system updated. This is a really important one. If we go back to that machine that we were just looking at there, let's go full screen on this one again. You can see, because I'm logged into this graphically, I can see up here there is a little symbol that tells me that some updates are available for this. We can see that there's a whole bunch of updates that are available, and I can just hit that install button there, and it'll go away and it will install them. Now if I didn't have access to this through the graphical interface, let's jump back to the Raspberry Pi Connect screen here, for example, and let's connect to that same machine but using the remote shell instead. So here we go. So it's just going to take a second for it to connect to that, but it's exactly the same, but it's just using the terminal instead. So if we do sudo apt and then update, that will do the same thing as that little utility does in the background. It will check to see, based on the latest available updates, and it has to go online to check that, what is available. And then it comes back and it says 233 packages can be updated. So that's good news. That means that we can update them. So we can, instead of doing update, we can do upgrade. And if you do -y, it won't ask you, would you like to install these? It'll just say -yes. It'll automatically install them. And we can leave that going and it will patch the machine. Now, if you've got a lot of machines, that's a lot of patching. I've got a bonus tip for you at the very end of this video that I can show you how you can patch all of your machines in one single command, which is really quite useful. So keeping machines up to date are very, very useful. So how often do we need to do this? Probably need to do this. I do it about once a week, I think. But about once a month is probably safe. Depends how often the security updates get sent out. And what kind of problem can this solve? Well, outdated software can actually create security vulnerabilities. So hackers find exploits in existing code, and if you've not patched your machine, then you have that exploit, you have that vulnerability. That means that people can use that to attack your machine. And this is how a lot of companies are being broken into and their machines held to ransom. What attackers actually do, this is a typical kind of cyber attack. They'll find a known vulnerability in, say, Windows, Mac OS, iOS, Android, Windows Server, or Debian Linux, whatever you happen to be running, and they will have a they know that this vulnerability allows them to get access to the machine in some way, and it might just be that they can create buffer overflow or some kind of crash where they can inject some further code and then take over your machine. And one of the common hacks is called a ransomware attack, is where they will encrypt your drive and only they have the key, and you have to pay them some ransomware, usually like a Bitcoin, because that can happen without it being traceable. So they can ask for some money, you give them money, they give you the key to unlock it. But typically what they do is they don't give you the key right away, they double the ransom that they previously asked for, you then pay, and then hopefully they give you the key to unlock your drives. The counter to that is backing up your crown jewels, whatever data is important to you, on a separate device that they can't access. And you can also back up in a way that can't be deleted. So you can write once, and that is essentially locked into that backup device until a specified amount of time. It's usually built into the software itself. So patching your software, really, really important. Saved my skin a number of times. I used to work back in the day in a college, and lots of other colleges had Windows machines, and we would patch them when new software came out, and I was always on top of this. And some places never patched their machines, and what would happen is a new virus would be available, like WannaCry, or what was the one? Was it called Blaster or something? There was essentially like a worm. It would install itself on a machine, and then it would look on the network to see, are there any of the machines with the same vulnerability, and then it would install itself on them and keep growing and growing and slowing them all down. But because I patched my machines, we didn't have that issue, whereas the local authority, they didn't have an updated version of, they didn't patch their machines, so it would just go rife, and they had a lot of time just trying to whack-a-mole this particular issue. So keeping your machines updated, really, really important, and you can see how simple it is to do. Just sudo apt update, sudo apt upgrade, and away you go, you're nice and patched there. Okay, so let's get back to our tips. Let's have a look at the next tip, which is tip number 3, backing up. So backing up is actually really trivial to do on a Raspberry Pi. Just need another device to copy your files to. I'll show you how to do that. But yes, it's nice and simple. Let's go over to one of these machines here. We'll do this one, for example. So on here, we'll run the command. There's a number of different commands that we can use to back up, but the easiest one is to use tar. Tar is tape archive. It's from the back in the days when people used to use physical, like reel-to-reel tapes for loading software, backing up things, and it's very, very cheap tape. So tape archive is where the tar command comes from, and we're going to use these 4 letters. So -C, Z, V, and F. So the C means create a new archive. The Z means compress the backup file as a zip file. V means verbose, so show every single file and folder that we're backing up. And F means specify the file that we want to back up to. So we're going to specify the name of the file. We're going to call it backup.tar.gz. GZ is the zipped version of our tar file. And we're going to back up everything that's in the etc, the etc folder. This is the V for verbose, so it's backed all that up. If we now do ls, we can now see we have the backup.tar.gz. If we do ls-h, we can see there It's only 2 megs in size, it's quite small. We need to get that file off this machine onto another machine so that we've got a backup. So we could use a USB drive to copy that across to. We could back that up to a NAS drive or another machine somewhere else. But essentially we need to get that backup file off this machine so that we have this backup. And to restore it, we essentially use the same kind of command, but instead of encrypting, zipping everything up, we're going to unzip the file instead. But that's essentially what we need to do, is back up with a tool like this. There's other ones available as well. We have things like rsync. I think that's a very strange word, but yeah, rsync is like remote sync. I use this a lot on my own backup server, so I have a NAS drive, which is just over there. Sometimes you can hear it sort of chunnering away. It's a Synology NAS. And I back up everything to that, and I then copy as a backup of my backup to another, to this NASy NAS that we created a couple of weeks ago, which is in another part of the house. It's a different physical building than this one that I'm in, so if this burnt down, we've still got a physical copy on site of those files. And I use rsync to remotely synchronize those files across from one device to another. Okay, so why would we want to do this backing up? Well, SD cards fail. I have a little graveyard here of all the SD cards which have failed on me. If I jump over here to my overhead, you can see there's a little graveyard here of all these SD cards which have failed on me, and some of them are quite expensive ones as well. Depends how you use them. So that one is a SanDisk. SanDisk are quite good quality. It was a 32 gig one. The most common ones I find that have failed on me is the unbranded ones, or the ones that are branded as Samsung. I've had quite a few of those fail. And they seem to fail after a couple of months or years. So if they've been outside as well, if they've been in a Raspberry Pi, I had one like as an outdoor camera. That one was, I think, a couple of seasons. So it was outside when it was really, really cold. Like freezing conditions, and it really wasn't designed for that, the SD card. So you can buy SD cards which are designed, I think they're called like extreme, or they have a kind of robustness to them. So when you're looking at SD cards, don't always choose the cheapest one. Look for the ones that have got the longevity and can sustain lots and lots of writes to them. So yeah, SD cards fail. You can also accidentally delete things or change things, which can cause corruption or data loss. So that's something also that we want to prevent. Okay, so let me see if there's anything else I wanted to cover off on there. So how do we automate the backup? One of the things that we might want to do to automate this backup, let me just jump back into our screen over here. There is a scheduler on Raspberry Pi OS. So this is called the cron or cron tab. Cron tab is the table which has all the cron tasks in it. Cron is like the background scheduler. And we can use Nano there to edit this. And if we scroll down over here, you can see we've got this quite esoteric looking way of putting the commands together. So the first thing we need to specify, and I've written this up on kedsrobots.com just so that you've actually got this information a little bit more easier to consume. The first figure that we put on our cron tab is what is the minute. So this is a number between 0 and 59. So which minute of the hour do you want this to occur on? The next one is the hour, so 0 to 23, 24-hour clock. So when do you want this task to actually start? What hour? Then we got the day of the month, so 1 to 31. Then we have which month, and then we have the day of the week. So we can alternatively not have any of those selected and have this one running on a different period. So let's have a look what this is. So this is saying 5 a.m., which is what that says there, every week. So this is the day of the week, which is 1. So that will be Monday. So every Monday, this will run this particular task. And you can see there it's saying backup. Everything that's in the var backups home folder into this, everything that's in the home folder into this var backups home.tgz file, which is a tar gz file. And crontab will then take that and it will run with that. It'll make that happen. So if we wanted to do that, for example, we could say 05 star 1, and then we could do that tar. We could run that same command that we just did. So czvf, and then we did backup.tar.gz, and then we want to say what it is that we want to back up, so it's everything in the etc folder, for example. And if we then exit out of this, we do Control and X, yes, to save the buffer. It'll then write that. It'll then run that in the background at 5 o'clock every single Monday, which is what we've specified there. And it'll overwrite the previous file, so we would have to make sure that we copy that file to somewhere else. We could have perhaps a little script that does all this for us. So cron tab are really useful. Again, if you go to, let me jump over to kevsrobots.com and I show you that to load up. So I jump to my local version of this, how to keep your Pi happy, and we scroll down here to accept that. You'll find the cron tab information, so the 5 stars represent minutes, hours, days of the month, months and days of the week, in case you want to choose that instead, and then what is the command that you want to execute. Great, so that is a tip number 3, back up your files. And I can't really emphasize enough, if you're not backing up your files, you really are living on the edge, because hard drives do fail, SSDs do fail, people do get things stolen from them. So having a backup copy and having that automated so you don't even have to think about it is really important. So please do this if you haven't done this already. Okay, next up then is monitoring system performance with HTOP. Right, I'm going to jump over to another Raspberry Pi that I have running. So let me just jump over to dev number 2. And I'm just going to go full screen on this one again. So I've got HTOP running on here. Let me just quit this, and if you type in HTOP, let's zoom in on that a little bit more so you can see what I'm actually typing in there. So the top command shows you a list of all the processes that are running. It's kind of like a task manager. I know on macOS and Windows, even on Raspberry Pi, there is a task manager that shows a very similar kind of thing. So it's all the tasks that run in and which user account they're running under. You've got all the other kind of information, but really we're interested in how much CPU usage are we using for this, and how much memory are we using as a percentage. Now top shows you quite a lot of stuff on there, but HTOP shows you this in a much more useful way. And the reason I like this is because you can see the 4 CPU threads that we have available, the cores that we have on here. We can see how much memory that we have on this machine. So we've got 7.87 gigs. So this is an 8 gig Raspberry Pi. And you can also see that there's a swap file, and we're not really using very much of the swap file, and that's good, because if we're using lots of the swap file, that's lots of writes to that SD card. It's going to harm the life of that SD card. It's also in colour, which helps as well. And we can see here that we have the top task. It's automatically sorted by CPU by default. So you can see there we've got this lab W. If we stretch this out a little bit, lab WC is actually the user interface that you're looking at right now. That's why that's taking up a little bit of CPU usage. And we can actually change that. You've got down here this sort by. So if you hit F6, you can specify, what it is you want to sort by. So you could have like, how much memory is being used, for example, or you could have like the default, which was the CPU usage. So if you see any tasks there that are running really high, you can actually kill them. You can hit F9 and that will actually kill that. So if we find that HTOP command, let's put it onto HTOP. If I hit F9 to kill that task, it's actually killed the task that we're in. So that was how we can get in and out of it. You can also press Q for quit, or you can press F10 as well to quit. But I think Q is the easiest way. But I really like this tool. It's installed by default on all Raspberry Pi machines, and it's very easy to read. You can just see how busy this machine is at a glance. You can see there's not very much going on all 4 cores, therefore it's not really being very taxed. And we're not really using very much memory as well. You can see there the green is how much memory is being used, and we've got tons of memory free. This machine is really not being used very much at all right now. So that is how we can monitor our CPU usage very easily. So how often do we want to do this? It's really if there's a problem, if the performance seems to be slow, or it's very hot. If you feel the machine and it seems to be particularly hot, that heat's usually generated through the CPU. So why is that? And if there's some unresponsive applications, say your expecting this to be doing something and that isn't happening, you can log into here, do htop, and see immediately what's going on under the hood. And it might be that there's one process that's running, that's hung, that's taking up all the resources. It might be taking up loads of memory, it might be taking up loads of CPU itself, and you can kill that task from here just by selecting it and then hitting the F9. So really, really useful. It's a tool I use very, very often. Okay, let's get over to our next one. So tip number 5 is cleaning up the file system. This is quite an interesting one. Let's get my notes up over here. Yes, well, we'll get into what those journal files are as well. So I'm going to go back to, let's go back to this machine that we have here. We can see that we've got some updates ready on this one, and let's do that disk full and see what the situation is with the disk space as well. So 3.9 gig available, 840 gig available on the main drive, so plenty of space on this particular one. That's not a problem, but we can perhaps log into a different one and see if that's any different. So I'm going to log into, let's see, let's go into this one and see what this one is like, for example. So this has got a little bit more space. It's got 20 gig available, so it's actually got quite a bit. But we can play around with the next thing I want to show you. So if you have an SD card or you have an SSD drive, then the way that file system allocates space to blocks that are being used and then frees them up is a technique called trim. So let's see, does trim actually stand for anything? That's one of the questions. What does it stand for? I did used to know this, and that's SSD or SD cards. It's quickly googling that to see did it actually stand for anything, but it doesn't appear to actually stand for anything. But it's to do with how it allocates blocks. Essentially, they have to be ready to write to, and if you've already written something, you have to clear that block and then have it ready to write again. And this is what the trim command can do in the background. And periodically, your file system will have this happen in the background, but sometimes you need to sort of force this. So let's just jump back to this full screen. And you can type sudo fs, which stands for file system trim, and then you can say AV as well. And what this will do is it will fire off the command to the hardware and say start trimming your blocks and make that file available, make the disk space available. You can then check up on how that's going. You can do df-h. You probably won't see any difference on there because it's the allocated space rather than it's kind of behind the scenes at the block level rather than at the file system level. Next thing we can do is we can clear our cache of files that are installed. So before we used sudo apt update to update our machine, you can see we've got some updates pending to be installed here. We can have a look at that. Now each of these are actually taking up space, and the ones that have been installed are also taking up space. So we can do sudo apt clean to remove some of that. Now because this is actually being because it has these pending tasks in the background, it says this is currently being held. So we'll try that again and see if that's going to allow us to do it. No, it's not happy with that. So this is something we need to do when there isn't any updates kind of pending. What apt clean, and I think auto clean is another version of that. And there's auto remove as well, which will get rid of any packages that are not needed. So interestingly, that's still saying that. I wonder if it's because I looked at that earlier. Now it did actually tell us the process number 4838. So we could do htop, we could find that 4838 in the PID number down there, and we can probably just kill that particular task. So was it that one? 4838. There it is. So that's that apt upgrade -y. That seems to be running in the background, so we could kill that task like that. And we can then quit out of here, and let's try just doing that auto clean again now. probably not a great idea to be doing that while it's actually doing an update. But I think I must be logged into that via another route as well. Perhaps it's via the other. Yes, it's probably by this one here was running that, and you can see that it's just waiting for me to complete that action. If I let this finish, we can actually do that auto clean and get rid of any updates that are pending, any files that have been installed, and the file is just there waiting to be removed. It'll keep them just in case it needs to uninstall them. So typically the file that gets installed can also be used to uninstall it, the package, but we can actually remove them totally and just have it re-download them if we need to do any maintenance on that. So let me just wait for that to finish a second, and then I'm going to show you some other really useful commands. So while it's doing that, we'll just leave that there. So we were talking before about the journals. So if we go to, let's go into our var and log folder. Let's do lslh. We can see on here we've got a whole bunch of files, lots of log files. These are automatically generated by the system as it's just doing stuff in the background. So the boot log, every time we boot up, all the output that you see on screen gets logged to a file, and that's just in case you need to look at that. We've got the package log. Every time we install a package or uninstall a package, they get logged to this dpackage.log. And we've got these other log.1, log.2, log.3, and these ones are all zipped up as well. And these are all just sat there taking up space. And these are one of the easiest ways to free up space. We don't really need the log files. We only need them if we want to troubleshoot what's going on. So we can use some commands to see how much space is actually being taken up by this. So if we do sudo, then journal, ctl, which is like journal control, and then we do dash dash and disk dash usage. And this will tell us then how much space is being taken up by all those log files. We've got nearly a gig of file space being used just by these log files that are not really doing anything for us. We don't really need them. We can actually get rid of them. So we can do that by vacuuming them. I love this command. So we can do vacuum, vacuum. And then we can either do this by time. We can say time equals, say, 2 weeks, for example. Anything that's older than 2 weeks will be removed. Or we can, instead of doing time, we can say size. Now, this is one I prefer. So we can say vacuum size, and then we can say equals 10 M, for example, 10 megabytes. So if we now look and do the disk usage, we can now see that there's only 16 megs of file space being taken up by those log files. And if we do ls-lh again and have a look what's going on there, we can see that although these files are still there in the journal folder, they've been reduced right down in size. And again, we can actually just delete all those .gz files as well. You can just use the rm command. Let's just do dpackage log2.gz, for example. Yes, we want to remove that. Oh, let's do sudo remove that. Let's try 3, 4, 5 and 6. There we go. And if we want to, we can have these commands, we can kick off all these maintenance commands by doing sudo system control start fs trim.timer. And that'll make sure that those trim commands are running automatically in the background. So that journal command really useful for seeing how much space is being taken up. We can try that on another machine. Let's try this one here. I'm not sure if I've done this one already on here. So if we do sudo journal control and then dash dash, and it was disk dash usage. So this one has already been cleaned up by me, I think, at some point. Let us have a look at another Raspberry Pi. So let's jump back to all the Pis that we have on here, which is here. And these are all my Raspberry Pis that I've got connected up. So I'm going to look at, let's see, Arcade 2. Let's go for the remote on that one. Let's see if we can make that a bit bigger as well. So if I do sudo system, journal command, journal control, ctl --disk -usage, 10 megs of system space, so not a great deal being taken up there, but we can do that vacuum dash size, and then equals, say, 5 meg. There we go, we've got rid of 6 megs of stuff, so if we now run that disk usage, it's now 4.5 megs being taken up, so really useful to sort of vacuum, just like you would vacuum your house, you can vacuum your file systems. I love that. Okay, next tip. So the next tip is you need to like this video. If you like these videos and you want me to make more of them, please drop a comment, let me know. Just type the word Raspberry Pi in the comments if you want me to make more Raspberry Pi content, and I shall get into that right away. If you're not subscribed to the channel, please subscribe. It means so much to me when people subscribe to the channel, particularly when people are not sitting and watching videos like this during the summer months. It means so much to me that people do actually still subscribe to the channel. And I do go live every single Sunday, 7 o'clock British summertime. It'll be GMT when we get into the winter. Right, power supplies. Now, your Raspberry Pi can run on essentially a phone charger. I've got this Apple charger here. This one will provide 5 volts, which is what we need to run our Raspberry Pi. But then it comes down to how many watts can you provide. So this particular thing, I can't actually see what this says on here. But Raspberry Pi do a number of different power supplies depending on your needs. So they do these little square ones. This one's a little black one. This one's got the USB-C connector on it. And this one, I think, is a 15-watt power supply. This is usually okay for Raspberry Pi 4s. Raspberry Pi 5s may struggle depending on what you're doing with this. If you're hitting all 4 cores with some kind of AI large language model, this might not be enough power. So they do a slightly larger one, which is the 27-watt power supply. Let's grab this here. So let's go full screen on me for a second. So this is the 15-watt version. This is the 27-watt version. And they also do a much larger one, which is the 45-watt version. So this is the 27-watt version. There we go. And yeah, this one is perfect for Raspberry Pi 5 for pretty much most use cases. So I have a bunch of these powering that little cluster of Raspberry Pis behind me. That's running KezRobots.com as we speak. So the tip here is consider what kind of power usage you're needing for your Raspberry Pis. If you're connecting up some hard drives externally to this for a backup or a NAS drive, then you're probably going to need more than the absolute bare bones 5 watts, which I think is what you probably need for, not 5 watts, is it 2 point something amps. Let's pull up the exact spec that's required for Raspberry Pi. And I've actually got the Raspberry Pi website open here. Let me jump to that. I'll show you the different power supplies that they've got there. So the 45 watts, that's their super powerful version. This one is for Raspberry Pis that have got things externally connected to them, like hard drives. The 27-watt version is more than powerful enough, and this is designed for the Raspberry Pi 5. These ones have the power management. They can talk to the power management chip on the Raspberry Pi 5 and provide power intelligently. The 15-watt one, which is the little square one that I showed you earlier, these ones are ideal for the Raspberry Pi 4, the Raspberry Pi 400, and I think 500 as well. And then you've got these 12.5 watt micro USB versions. So they're the ones that have the micro USB connection. They look very, very similar to this one, but they have a different connector on, and they're really designed for like the Raspberry Pi 0 and Raspberry Pi 3s and older. So definitely buy the right power supply for yourself. And these are not expensive. This one's $15, for example, for the 45-watt version, which is more than enough power. Probably a bit overkill, I would say, on that one. So definitely do consider what your power requirements are for your Raspberry Pi and make sure that you have the right power supply for that. You can use a phone charger, but you're going to run into some kind of issues. The kind of issues that will present themselves are random reboots. You might get SD card corruption happening because there isn't enough power to write to the drive. You might get some warning icons on the desktop. You get this little power icon sometimes appearing. You used to get little like a rainbow symbol in the corner of the display. But now you just get this warning icon, and you'll also get slow performance. So the Raspberry Pi 5 is very intelligent. Depending on how much power you provide it, it can actually dial back the CPU usage to make use of the power that's available. So if there isn't enough power, it'll actually slow things down a little bit. So using a high quality official power supply is definitely the way to go, but failing that, just make sure you've got enough power for your usage there. Now we can actually see how much voltage we're using on the Raspberry Pi itself. If we go back over here, let's type in this command. So if we do vcgen cmd and then get throttled, it sounds like an insult, doesn't it? Get throttled. Throt. There we go. And that's telling us that that'll check for voltage problems. Let's see what that actually means. So get throttled. Just googling that to see what these actual symbols mean. So let's see. And which Raspberry Pi am I on? I'm on the Node 2, which is a Raspberry Pi 4, and 5000. Is there a response? Yes, there's a little table. I'm just trying to find that so I can bring it up on screen. It's kind of like a binary thing. Let's go for that. So 5. So there has been an undervoltage at least once. I think this is what that's indicating there. It'd be good if we actually have an example of this. Now this is on a Raspberry Pi 4. Let's try this on a Raspberry Pi 5. Let's go to, let's say, the first page on here. Let's go for Dev 001. Let's go for remote shell. Oh, actually, let's go for, close that. Let's go for the shared screen. We can zoom in on the terminal, which makes it a bit easier for you to see on screen. And we'll try it on here and just see if this is any different. So let's get back to that command again. So vcgen command get throttled. It's taking a while to connect to this one, isn't it? I wonder if I've still got dev2 open. If we have, yeah, we'll try it on here. So vcgen cmd and then get underscore throttled, wasn't it? Yeah, so 00 means it's got more than enough power. It's not had any power supply problems. It's very, very happy. So that's definitely something for me to check out on that Node 2. Why did that one have that 50,000 message? And we can look into see what that's all about. Okay, tip number 7 then. So this is about cooling. So your Raspberry Pi, particularly if this is a Raspberry Pi 5, it will need some kind of cooling to keep the system from overheating. Now you can get the official Raspberry Pi case. These ones come with this very, very simple fan. You just connect this up into the to the fan connector on the motherboard, and this will intelligently come on and off depending on what the core temperature of the CPU currently is. And we can use that vcgen command again to find out what the current temperature is. So if we go back over there, let's use that vcgen, but this time we are going to use the measure temp command. We can see there 48.8 degrees, which is fine. It doesn't require the fans to come on at that kind of temperature. I'll just grab one of these other ones. So this one, I just switched this off actually. So this is the Raspberry Pi Touch Display 2 5-inch version, and I have a Raspberry Pi 5 on the back here, and I've got these nice little feet that I've created. These are available on printables.com if you wanted to grab a copy of these. But you can see on there I have this this silver thing. This is an active cooler. So this is an official cooling fan for the Raspberry Pi 5. It has this great big heatsink. It has some nice thermal pads that connect to the 4 main chips on the Raspberry Pi and provide cooling directly to that. And this will spin up if it requires the fan to come on. It's very, very quiet. This is a very high quality active cooler. So that's something that you might want to look at as well. Just going to plug this one back in. And when you plug this in for the first time, as you plug this in, that little fan will spin up momentarily. You'll probably just see it in a second. Spin up, and it's basically just checking that everything's working. It just span up just for a second then, and then it stopped. Now there you go, it's spinning again, and then it stopped. So if you're doing something that's very, very CPU intensive, you will find that the fans will come on. If I run a large language model on my Raspberry Pi 5 array behind me there, I'll hear the fans kick on, and yeah, they'll provide some cooling for that. So cooling is really important. If it's above 70 degrees, consider a heatsink or a fan, and I'm sure your case that you're using also has good ventilation as well. So I was playing around with some cases earlier. So this case is for a Raspberry Pi 5, I think, and this one is a 3D printable case, and this one, interestingly, doesn't actually allow you to have the active cooler installed when you're using it, but there is a space there for a fan to be attached, but I'm not sure what fan that is. I thought it might be this little one, but it's much bigger than that. So this was just available on printables. So yeah, definitely think about that when you're creating your own case. You need to have some kind of air vents in there and some airflow. Cool. So anything else we need to think about on there? Yeah, check temperature of any heavy use, or if it's in hot weather, or if it's in a space where the temperature changes a lot. That's also not great for Raspberry Pis. I have had these outside in all weathers, and I think it's the SD card that sort of clonked before the actual Raspberry Pi Zero itself. I have some Raspberry Pis that used to be in the loft. They would get very, very hot in summer and very, very cold in winter, and that kind of dramatic shift in temperature isn't great as well for Raspberry Pis. And there is actually a new Raspberry Pi compute module, which is like their extreme version, and that one is designed to be able to work in extreme temperatures. So all the components on there have been designed and tested to work at extreme highs and extreme lows as well. So just make sure you've got, again, your Raspberry Pi is geared for the environment that you're using it in. Okay, let's get to the next tip. The next tip is surge protection. So one of the reasons my SD cards have failed in the past is if there's some kind of power surge. So if the power spikes and goes off, that can actually cause all kinds of damage to your very delicate SD card. So one of the ways that you can protect that is by using a surge protector. So this little SanDisk Ultra 32 gig bit the dust, and it was most likely to do with some lightning storm, and I didn't have that one on any kind of surge protection. So I have quite a juicy surge protector down here. It's actually a UPS, and that's connected to a Raspberry Pi as well using that NUT service, the network uninterruptible power supply service, and that means that it can detect and actually correct any kind of voltage issues. So if the voltage drops or spikes, it will soften them out, because essentially it's running on the battery all the time, running through the battery, conditioning the power that comes through, and if there's any kind of loss of power, it can immediately switch to that battery without any kind of loss to the Raspberry Pi. It will carry on running. You can also get surge protection built into power strips. So they usually specify on the power strip when you buy them that it has a surge protection, and they will also tell you what kind of surge protection that is, like what kind of quality of that. I'm just trying to find a browser window to quickly open up, and we can have a look at what that looks like. So if I go to Amazon, for example, surge protected extension lead. So here we go, let's go for that one there. So not sponsored by any of these are just ones that I typed in, and typically, yes, it will tell you that it's got some kind of surge protection. Now these tend to be able to suck up most problems that you might find on your power grid. Depends what country you live in, what kind of power problems you're likely to have, but these ones typically soften out the smaller kind of problems. That they haven't got any kind of battery backup, they're not conditioning the power as it comes through, they're just going to stop the kind of very high swing that you might get from the power just immediately surging. It'll just stop that from happening. You can see here these are not too expensive, they're not that much more than a regular extension cord, power strip, whatever you want to call it. So if we go for let's go for a UPS instead. I'll try and find the one that I have under my desk. which I think is similar to this one. It's not an APC, I think it's a Cyber Power is the one I have. Let's search for that one. There we go. And the one I have is that one. So it's quite expensive. It's about 10 times more than the Surge Protector. But this one has a very large battery in it. This one has a 1200 VA or 720 watt battery in it. And it even has a USB charging port on there. And you can see there you've got three Surge Protect sockets and 3 battery backed ones. So these are the Surge Protect on the top and the battery backed ones, which is also Surge protected underneath. And this one will tell you what the current voltage is. So I can't actually see from here what the current voltage is, but yeah, in the UK it's somewhere between 220 and 240 volts. 230 would be sort of a normal kind of voltage, but it might swing up and down depending on just local demand. Now during a thunderstorm, if the lightning hits the power line, it'll suck up some of that power, and if you're unfortunate, that'll go straight through to all your electronic devices and will cause issues to them. So something like one of these UPSs, that's, you know, the ultimate solution, but you do pay quite a bit of money for that. So I think I've got 3 of these in our house. We have one which is connected to our Wi-Fi and our broadband router, so we've always got that on even if there's a power outage. We've got another one in the loft which feeds the main kind of central network connections, and then that comes out to here, which is in the summer house in the robot lab, and we have one down here which connects to all the machines that are in here, or certainly a subset of them, maybe not all of them. Cool. So yes, surge protection is definitely something that you want to have. Protects from power surges and outages that can damage your Pi and corrupt data, and the kind of thing that you would see on there is that the Pi won't boot after a storm. You've got a corrupt SD card, and maybe you've got some other hardware failures as well. Things connected to the GPIO pins, they might also have issues. So UPS, if you can afford it, and failing that, surge protected power supplies are the way to go. Yes, that's everything I need to cover off on that one. And tip number 9 then is changing the default passwords. Now Raspberry Pi actually did do this by default when you install using the Raspberry Pi Imager. It's no longer Pi, which is the default user. So on that very old Raspberry Pi, which I have on the desk next to me, if I bring up, let's just connect to this, I shall share my screen so you can see what's going on. So I think this is called Pi, and then what was the IP address that we had on there? 154. It's actually installing some updates at the moment. We can connect to this. It'll just be a little bit slow because it's installing some quite chunky updates as well. So I'm just going to type in my password there, and then we should get in there. So this is a Raspberry Pi 1, the very first generation, and I think this is the 512 meg version, so it's the kind of slightly larger memory compared to this one here, which is the 256 meg version. So if I do htop on here, we can have a quick look on here. So you can see there it's got 430 megs of available RAM, and it's currently using 60 megs of that, but the CPU is maxing out 100 because we're doing that install of all the updates. The thing I was going to talk about on here is, yes, the actual user account that I'm using to log in here is Pi, and that's because can we actually list out the users on here? Is it W? It tells me who's logged in. So I'm logged in from another machine there. You can see they're all using the Pi user. And the reason this isn't great is because everybody who is a hacker knows that the default username on a Raspberry Pi is Pi, and the default password was Raspberry. So if you want to get into almost all of that generation Raspberry Pi, so anything that was before we had Bullseye or Bookworm OS, had user as Pi, and the default password was Raspberry. So very easy to guess and hack. So if you work in in a factory and they've got Raspberry Pis installed on gantries way up high, you know, more than likely it is that they've still got the Pi username and default password on there. So you definitely want to check that you have you've changed that, and that will prevent any kind of vulnerability attacks through that known user account. So prevents unauthorized access, unauthorized changing of settings and files, or even compromising the system completely. And all it takes is just that changing the password. So you can do that if you type in passwd. You can actually type in what the current password is and change that password to something else of your choosing. If you're logged on as an administrator, you can actually do, let me just come out of this one. So it's been a bit slow because of the updates that I'm installing, so let's just go to another Pi for here, for example. So you could do passwd, but if you don't want to do that, you can also do you can do sudo passwd, and then the actual account that you want to change. If I do that, I can just type directly in what I want the new password to be, and it'll change it without me knowing the existing one. So you can only do that if you're a super user. But definitely create a new account. So I use a different not Pi on a lot of my Raspberry Pis. Cool. Let's get back to our tips. And tip number 10 is documenting your setup. So this is really, really important if you want to have any kind of longevity of your Raspberry Pis. So I started in, I think, Google Docs, putting together what my documentation is for my Raspberry Pi setup. I now use Obsidian for this instead. So if I go to my Obsidian, let's go to, so I've got containers. These are all the different software I have installed on my Raspberry Pis. And I can also look at which nodes I have installed. So these are my Raspberry Pi nodes and what I've installed on them. So the way that I've done this in Obsidian, if I just click on this node 2, for example, so the type of thing is a node. I don't know if I can get this to zoom in at all. See if I can zoom in a little bit. There we go. Might be a bit easy for you to see if I just close that out. So we did a video on Obsidian last week. These are different front matter properties. So the topics on here: Clustered Pi, which is the cluster that these are running on, and KesRobots is the name of my website. This was when I documented this particular one, so back in June the 11th. And then the containers that are actually running on this machine. So we've got the search app for the KesRobots.com website, Clustered Pi container, the random fact container. We've got Telegraph, which is a kind of statistics monitoring thing, and we've also got an Alarm container on there for AI, large language models, and it's currently running Bullseye. Node 2 is actually running Bullseye, not Bookworm, so it's running quite an old version of Raspberry Pi OS, and that'll get replaced with Trixie when that comes out sometime this year, I guess. And that one is a development machine. And it can also actually be a production machine. I think there's a few things on that node which make it production as well, so probably best actually being a production machine. But exactly how these things are set up, so I can then document that, how to set up the search app, where the files are for that, all that kind of stuff in here. But previously I've done all this as a Google Doc, so if I just going to find that in my Google Docs thing. I'll show you what that might look like, for example. So let me just find that. So let's go for this one, for example. So this very uninteresting looking doc here is a Z-pool storage pool thing. This is when I used to have a FreeBSD machine. It's actually just underneath my desk here, but it's no longer running, but it had a whole bunch of disks on there. So what's that, 6 disks is that? So 6 1 terabyte disks. There's an SSD cache drive, I think there's another cache drive there as well, and this would help me understand what they were connected to, what ID number they were connected to. So that's the kind of thing that I would do to document my setup. Excuse me, I'll see if I've got a slightly more interesting one than that, because that doesn't look great from a documentation perspective. I also don't want to share too much details on here, but this is probably a better one. So clustered Pi setup, so you can see there we've got the IP addresses that I use to connect to that. This one had issues with the SD card, interestingly. You can see there that Clustered Pi is hosted on port 2222, KesRobots is on port 3333. And in fact, when I connected to that before, you can see there that's also still running on port 3333. as well. And we've got some other configurations like how much RAM they've got, what kind of Raspberry Pi they are, what operating system they've got, what SD card they've got on there. And I think that's pretty much it on there. But by documenting your setup, you will forget in time how you've set that up originally. Perhaps the reason for it, the choices of things that you installed on there. So it'll prevent you from forgetting how you set something up. And hard to fix issues are easier to fix if you've actually got how you set this up in the first place documented somewhere. So keeping notes, version control notes are even better. And yeah, very, very simple way of documenting this. You can actually do this from the Pi itself. Let's go over here and we can type in, for example, I made a real dog's dinner of that, haven't I there? Let's just type in the password incorrectly. There we go. So if I type in dpackage and then --get and then the selections, that will tell me all the things that I've got installed on that Pi in the way of kind of software packages, and I could pipe that out to a file that's called packages.txt, for example. So if I now look on my file system, I've got that packages.txt. If I cat that packages.txt, I can see exactly what we had there. So that's the kind of thing I would typically put into the documentation. I might just copy and paste that into like a Google Doc so I know what I've got installed on there. Now, one of the things I did a while back, remember when we were looking to see what was installed on the Raspberry Pi? Let's load that one up actually. So it was it Devo 2? When we did the NCDU, there was a folder which was huge, which was called Clustered Pi. So this one here. So if we go into that Clustered Pi folder, this is where I set up all the templates, if you like, for my Raspberry Pis. So if I go into stacks and I have a look on here, all these different folders are Docker files, so I can very quickly spin up another instance of kevsrobots.com, or when I created a ROS2 robot, I go into ROS2 for example, I can see that there's a Docker file. I can just do Docker compose up and it'll bring up a container with all that configuration and the documentation, if you like, of how that's put together. If I do cat docker-compose, that's part of the documentation, and the other part is the Docker file itself. So if I do cat docker file, this is essentially how to build that Docker container. All the commands there run and will build that Docker container. That is a form of documentation. It's version control because it's in a Git repository, and all I need to do is do git clone clustered pi, and it'll download all those things onto my machine so that I can get up and running very, very fast, and I don't have to remember the configuration. I just make the Docker containers spin up. So the effort is in building the Docker container, but because you build that with text, it's kind of self-documenting. So it's a really good technique for self-documentation, and because it's stored in Git, it's not quite a backup because Git could get compromised, but it's not locally on my machine, so it's got another form of protection there. Okay, so documenting your setup, really, really key. And I did say before, I have a way of updating all my Raspberry Pis in a single command. So tip number 11, which is our bonus one, is using Ansible to script your setup. So if I go back to that exact screen that we were just looking at a second ago, so let's just jump back on here. If I jump back 2 folders there, I've got this playbooks folder. If I go into playbooks and I have a look, I've got all these YAML files, and these YAML files are Ansible playbooks. So Ansible is a piece of software, I think it's actually a Python based scripting tool, and this will allow you to deploy software to a number of different machines in a single command, and it's idempotent, so you can run this many, many times and it will always do the same thing whether it's installed or not. And one of the commands I've got on here is apt update. So if I do cat apt update.yaml, we can see here the let's just zoom in a little bit more on that so we can see that a little bit better. We can see there that the tasks are apt updates. That's the name of the command. The command itself is sudo apt update, and then it will even do a sudo apt upgrade-y to automatically apply those updates, and it's going to be applied to all hosts. So I have got a course available on Ansible. And there's a really cool book by Jeff Gehling. That's one of the reasons he became so famous, is because he wrote the book on Ansible. But if I go to kevsrobots.com, I'm just going to have a quick look and see if I can find that free course. I'm pretty sure I have a course on Ansible, and if I haven't, I will create one. Ansible. I'm pretty sure I did do an Ansible course. So let me see if I can find that one very quickly to bring up on screen. It may well be one of the courses that I didn't actually publish if it isn't available on there. So let me just check and do Ansible. In that case, it might be a blog entry. Let me just find that. I'm going to search on my website, because we did do a show on Ansible a while back. There we go. Let's see if we can find it on that list of shows. So you can't see what I'm doing at the moment. I'm just on my other machine. So Ansible. Automate Ansible Cluster Part 3. So I did a show on Ansible. So yeah, Automate with Ansible Clustered Pi Part 3. So if you seek out that video on YouTube, I'll show you how you can find that from Kev's Robots, in fact. So let's jump to Kev's Robots. Let's close down some of these windows. Kev's Robots. So if you go to videos, list of shows, and you just do a quick search on that page for Ansible, you'll see there that there's a Automate Ansible Clustered Pi Part 3, and there I am, and I talk you through basically how I've set up all these different scripts, how the scripts are put together, and then some examples of actually deploying software. And you can see on that little screenshot there, we have this inventory.ini file, and that lists all the different machines' IP addresses. You can either have the host name or the IP address, and as long as you've got this inventory file, you can essentially run that apt update YAML file and have that be deployed to all these machines and then run on them as if you're logging in manually and doing an apt update on all of them. So if you have a classroom full of Raspberry Pis, or you've got many Raspberry Pis over yourself, you don't have to individually log into each one once a month or whatever, or do any of the commands that we've looked at today, like backing up, for example. You could just have an Ansible script that will apply all those automatically for you. So Ansible is the way to automate your setup. So if you want to join our Discord community, head over to kevsrobots.com/discord, and you can get a free sign-up link and join our Discord community. It's a really great place to sort of share projects you're currently working on, pose questions to the community, and just generally hang out with like-minded people. It's completely free, and all you need to do is just head over to kevsrobots.com/discord to get a free sign-up link. And if you want to follow me on social media, I'm on all the social platforms. So I'm at Kev McAleer at threads.net, on Threads, on TikTok at KevMcAleer6, on Instagram at Kev McAleer, on X at KevsMac, on Mastodon at KevsMac at mastodon.social. I'm also on Blue Sky at kevsmac.bsky.social as well. I tend to post pictures of projects I'm currently working on throughout the week. So if you want to sort of hang out on there, be sure to follow, say hi, and share a picture of what you're working on as well. That'd be also quite cool. And if you want to follow me and join the group of people supporting this channel, you can do that a number of different ways. Head over to kevsrobots.com/coffee for all the information on how to do that. And I want to give a shout out to the people who have done exactly that right now. So if we look over here on the left hand side, we have Alan bought me a coffee recently. Thank you so much for that, Alan. I know you enjoyed the show that we did a couple of weeks back. Thanks, Tom, for the coffee as well. And Marie Mayer bought 3 coffees this month as well, so thank you, Marie, for that. Really do appreciate it. And we've got a number of different people over here who have subscribed to the Buy Me a Coffee membership. So we've got Anonymous, Silicon Fiber, Marie TKD, we have Jeff Johnson, Dean Corty, Marlene Brent, and Tom. And then on the right hand side, we've got our YouTube members. So we've got Allsrad39, we've got Warren Packard, we've got Brian TW, Pierre Eves, is that Blanchet, terrible at names. Got Bert, got Marie, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie. Hope the arm's doing better, Cassie. Tinkering Rocks, Johnny Bates, and of course we have Tom. So thank you all for supporting the channel. It means so much that you continue to do that, and it means I can buy these things to continue the channel as well. So yeah, thank you once again. cool. So if I now jump back to my slides, the little spinny logo there means that it's at this point in the video that YouTube will recommend a video over here for you to watch next. This one is from the over 430 videos I think we have now on the channel, so definitely check that one out. It's been selected, handpicked by the algorithm just for you to watch. And it's at this point in the video I'll say thank you so much for watching, and I shall see you next time. Bye for now.